Today we're going to review classifying numbers by number sets. So how many numbers are there in existence? A billion, trillion? Well, there are an infinite amount of numbers. To organize so many numbers, we need a system, and that system is the number sets. So let's think of different types of sets. One of the most familiar ones is probably geographical sets. So when we talk about geographical sets, we can organize into cities, into counties, into states, into countries, or countries go into the world. And we're going to use these same ideas when we organize our number sets. So our first number set, our smallest set, our cities, we're going to call the natural numbers, which the natural numbers are our counting numbers. There's no negatives, no fractions, no decimals, no zero. So we start at 1 and keep going. First set of numbers you probably learned. The whole numbers are going to be represented by the county, so they're just slightly bigger than our natural numbers. And they are the natural numbers and 0. So we add one extra set into that. Now when we start talking about states, we're going to think about integers. Integers are our natural numbers and their opposites, and of course 0, since 0 has no opposites. So we are talking about 1 and -1, 2 and -2. Notice we still have no fractions or no decimals. Now from states we can go to countries. When we're talking about countries, there are two different ways we can look at it. We can talk about our country, we can talk about internationally. So the first one, our country, rational numbers. Rational numbers, which our states would fit into, are the numbers which can be written as a fraction. Okay? These are going to be our fractions, our decimals that terminate, our repeating decimals, and all the numbers from our previous sets fall into this category. So natural numbers, whole numbers, integers, and are all rational numbers. Here's some examples. 5, because 5 can be written as 5 over 1. -3, because it can be written as -9 over 3. We are also including decimals, because decimals can also be written as fractions. Not all decimals, but most decimals. Ones that terminate and ones that repeat. So our rational numbers are numbers that can be written as fractions, or they're decimals, which are terminating or repeating. Irrational numbers are like thinking about a foreign country. They're numbers that cannot be written as a fraction. So, how do we know if a number cannot be written as a fraction? Irrational numbers have non-terminating, meaning they never end, and non-repeating decimals, such as pi. Pi is an irrational number because it never repeats and it never ends. There are no irrational numbers found in any of the previous 4 sets. So irrational numbers are separate from rational numbers. And finally, the all-encompassing big sets, or we think of our world, are all the rational and irrational number sets combined. So all of the countries combined. So let's look at a diagram here. Our smallest set is the natural. The natural helps build the whole. The whole helps build integers. Integers then build the rational numbers, and then the opposite kind of rational numbers are irrational numbers. And they all make up our real number system. Let's look at the numbers and list all the number sets it belongs to. So we have 8. Well, start with the biggest if you want. 8 is a natural number. It's also a whole number, an integer, a rational, and a real. -5, well, it doesn't fit in the category of natural or whole because it's a negative, so the smallest set it could be a part of would be integer. And an integer is also a rational number, and a rational is always a real. 0 is a whole number, which makes it an integer, which makes it a rational and a real. 7/2 is a fraction, which puts it into the rational category and also real. -4.18 repeating, or 18/100 repeating, is a rational number because it's a repeating decimal, and rationals are always real. And the square root of 2, anything that is a square root that is not a perfect square, like the square root of 16, is an irrational number. It's a never-ending, never-repeating decimal. But all irrationals are still real. I want you to take a second and use this number line to answer the questions. Pause the video, and when you're done, you can check your answers. Okay, which ones are the whole numbers? Remember, whole numbers are 0 and greater than 0. They do not include negatives, so C, D, and E. Integers are any of those numbers that are whole numbers or their opposites. So we would include C, D, and E, and we'd also add B. Which set does point E belong to? Well, E would be a natural number, a whole number, an integer, a rational, and a real. What number set does point A belong to? Well, we would probably assume if you said rational, it looks like it could probably be a fraction. But we don't have enough information to really make that decision. That's the end of our number sets, and I hope you learned a little bit today. If you have questions, bring them to class.